let's start with the sun. It emits all this electromagnetic radiation, but let's focus on the shortwave energy, which is light, and the energy coming from the infrared spectrum. The light we see enters the Earth's atmosphere. You can see here that some of this energy reflects back, some are being absorbed, and some are radiating back to space. This absorption and reflection of solar energy is caused by the albedo effect, which is brighter surfaces such as the clouds, snow, and sand reflect sunlight back to space like mirrors. Those energy that has been absorbed by darker surfaces are naturally utilized by plants and trees. These vegetations have efficiently evolved to use the sun's energy, which thermoregulates the environment. Within short timescales, human infrastructures remove these thermoregulating vegetations. When these plants are removed, the incoming solar radiation vibrates the surface molecules, thus converting it into heat. When you add in concrete jungles and the dark asphalt surface, during the day, those thermal energies given by the sun are being stored and accumulated within the urban environment. This is because these man-made structures trap these heat, like a blanket of some sort. In this graph, we can see that the urban area has higher temperatures compared to its surrounding environment. This is called the urban heat island. This happens because the urban surface, such as asphalt and concrete, acts like a giant heat reservoir. Furthermore, the heat generated by our energy consumption and the increased concentration of greenhouse gases emitted by anthropogenic processes occurring in the cities further contributes to this heating. Now, our objective is to either reduce energy use or health risk. And before we do that, we need to obtain the data. And these data could be air temperature, which is important for assessing heat island that are found within those urban canopy from ground level to the top of the trees, such as buildings. These can be either obtained by directly using standard weather stations and other monitoring instruments, such as mobile traverses. These monitoring networks and traverses typically cover just a portion of a city's area. They may not provide a representative picture of a citywide temperature, so we could use surface temperature as another source of data, which represents heat energy given off by the land, buildings, and other surfaces. And technologies that measure temperatures of surfaces could be instruments mounted on satellites and planes. These are either instruments that detects infrared, such as, for example, in Landsat, we use the band, I believe 4, 5, and 6 to detect infrared. Now, all of these sensors, whether it's ground-based or above the sky, uses passive remote sensing. And passive remote sensing uses other energy source to obtain that data. Active remote sensing is more rare in urban heat island, and it's when instruments creates its own energy and reflected back to obtain the data. Now you can see here an example here is using a geographic supplementary, differences between no buildings and with buildings. So it uses radio waves, and then those radio waves bounce back to the instrument, and you see the difference here. Now the third data that we need to consider is the temporal patterns. Now it's the differences in temperature through time. You can see an example here in a city in India that during summer and winter, the urban heat island is more evident
you can see the urban area is more higher than the rural area. Compare this to the monsoon season, and the red line and the green line is more closer together. That means urban heat island effect is more less. Now, the reason for this is rain and strong winds during monsoon season disperses the heat, and summer and winter, it's a relatively more stable climate, so the urban heat island is more pronounced. Now, there are considerations for measuring surface temperature, as surface temperature can be indirectly measured using satellites, aircraft, and ground-based instruments. While it is possible to estimate air temperatures from surface temperature data, the estimates are less reliable than direct measurements. Satellites provide extensive geographic coverage, but cannot portray the finer details of hotspots within neighborhoods. Trees or tall buildings may prevent satellites from accurately capturing the temperatures of surface at ground level. Data are collected only during the times when a satellite passes over a city and are available only for clear weather conditions. And these are the outputs. Example here. Now, ground-based thermal sensing are either done by these weather station or manually through handheld instruments or this car. Now, you can see here in the next slide, these are the raw data of those ground-based instruments. Now, you could assign those dots with coordinates. That's why they're in different positions within the graph. Now, within those measured instruments, they also measure the temperature. In this case, it's in Fahrenheit, degrees Fahrenheit. Now, you can see here it's classified into temperatures. In this case, it's in degrees Fahrenheit. And just add in the spatial extent, such as the city, and you have got the map. But it's not all that, it's not complete. So what we do is we do spatial interpolation. Now, to put it in a nutshell, it's basically knowing what's the unknown. What is between those? Well, you use statistics to do that. And these statistics are rendered by these computer softwares. And what these output does is produce a heat map like this.